Today we're going to be looking at a problem that involves proportional reasoning. This problem involves a directly proportional relationship, and we're going to solve it by using equivalent ratios. So let's start by looking at the problem. There are 270 grade 9 students at a high school, and 80% of these students attend the spring dance. Half of the grade 9 students who attend the dance buy their tickets at the door. How many grade 9 students who attend the dance buy their tickets at the door? So let's start by figuring out what information are we given. Do we know how many students go to this high school? 270 grade 9 students are at this high school. But how many of these students attend the dance? 80% of the total students attend the dance. We're also told that only half of the students who attend the dance buy their tickets at the door. So we need to figure out how many students who attend the dance actually buy their tickets at the door. So for today's lesson, we're going to use equivalent ratios to solve this problem. Recall that a ratio is a comparison between two quantities. So first we need to figure out what are the two quantities that are being compared. So let's break down this question. There are actually two different things that we need to find out. First, we need to figure out how many students actually attend the dance, and then we need to figure out, of these students, how many of them buy their ticket at the door. So let's start by looking at the number of students who attend the dance. What is the comparison here? What is our ratio? Do you think there's a relationship between the number of students who attend the dance and the total number of grade 9 students at the school? Yes, this can be a comparison that we're making. So, let's fill in the missing numbers. How many students attended the dance? We don't know that information, do we? So let's give this unknown information a variable. Let's let x represent the number of students who attend the dance. Do you know the total number of grade 9 students at the school? Right, 270. Now we also know that 80% of these students attend the dance. How can we write 80% as a ratio? Well, 80 would be the number of students who attend the dance, and because it's percent, what is percent always out of? What would be the total number if 80 of them attended the dance? Well, percent's always out of 100. So we can say that there's a ratio of 80 to 100. Remember, ratios can also be written as fractions. 80 out of 100 represents 80%. So now what? Well, before we skip to part 2, we need to solve for x. We need to figure out how many students actually attend the dance before we can figure out how many of them bought their ticket at the door. Well, now that we have two ratios set up, I'm going to show you how to solve this using equivalent ratios. So let's try that. So let's look at our two ratios. We have x to 270 and 80 to 100. Let's try and change this ratio into lowest terms. Can you think of a number that both 80 and 100 are divisible by? Just so that we can work with smaller numbers. Well, both 80 and 100 both end in 0, so I know that they're both divisible by 10. So let's start by dividing each term by 10. Remember, if you divide both terms by the same number, you're not actually changing this ratio, you're just showing it in a different way. What we're doing is finding an equivalent ratio. So 80 divided by 10 is 8, and 100 divided by 10 is 10. Do you agree that 80 to 100 is the same as writing 8 to 10? Do you think we can reduce this even further? Do 8 and 10 both have a common factor? Well, they're both even numbers, so we know that they're divisible by 2. So what's 8 divided by 2? 4. And 10 divided by 2 is 5. Now we have a ratio of 4 to 5. This represents 80 to 100. All of these are equivalent ratios because they represent the same thing. Do you think 4 and 5 can be reduced even further? Do they have a common factor? No, 4 is an even number, and 5 is only divisible by 1 in itself. So we've put 80 to 100 into the lowest terms possible. So now what? So let's set up our proportional statement. X to 270 is equal to 4 to 5. But now how do we solve for x? Well, in order to make two ratios equivalent, we have to multiply or divide each term by the same number. So that means that x multiplied or divided by something will give us 4, and 270 multiplied or divided by something will give us 5. But since we don't know x, we can't figure out what it's being multiplied or divided by yet. But since we have 270, the second term of the first ratio, and the second term of the second ratio, we can figure out what we would multiply or divide by. Once we know how we get from here to here, we can figure out how we would get from here to here. If you multiply each term by the same number, you're stating that these two ratios are equivalent. So we need to figure out what the missing factor is here. 5 multiplied or divided by something will give us 270. Do you think we would multiply or divide to get to 270? Well, since the number we're starting with is smaller than 270, we must have to multiply to get to a larger number. So 5 times something gives us 270. How are we going to find that missing factor? Well, remember, the opposite of multiplication is division. So if I take 270 and divide it by 5, we can figure out the missing factor. 270 divided by 5 equals 54. Let's check. Is 5 times 54 270? Yes. That means that we multiplied the second terms by 54. So what do we need to do with the first terms? The same thing. We would have to take 4 and multiply it also by 54. What's 4 times 54? That's right, 216. So the missing number is 216. X is equal to 216. Well, what did x represent? What were we trying to find? X represented the number of students who attend the spring dance. Well, now what? Well, now we have to do part 2 of this question, and that was to find out how many students buy their tickets at the door. So now that we know that 216 students attend the dance, how will we figure out how many of those students bought their tickets at the door? Well, the question told us that half of the students who attend the dance buy their tickets at the door. So now what is the ratio? What is the comparison being made now? Think about it. We're looking at a ratio of the number of students who buy their tickets at the door and the number of students who attend the dance. Well, we don't know the number of students who buy their ticket at the door, since that's what we're trying to find. So let's call that Y. We do know how many students attend the dance. This is what we just found out, 216. We're also told that half of the grade 9 students who attend the dance buy their tickets at the door. How would you express half as a ratio? Would you agree that a ratio of 1 to 2 shows half? Try writing it as a fraction, 1 over 2. That represents half. So the ratio of students who buy their tickets at the door to the number of students who attend the dance is a ratio of 1 to 2, 2 being the total number who attend the dance. 1 out of every 2 students buy their tickets at the door. So now what? Well, we need to find Y. So we're going to solve this again using equivalent ratios. So let's set up our proportion. Y to 216 is equal to 1 to 2. So now what? Do you remember how we solved the last equivalent ratio? How do we find the missing term? Well, each term is related by multiplication or division. Well, since we know both of the second terms, we can figure out what we did to get from one term to the other. 2 multiplied by something would give us 216. Well, if you can't figure out what that number is in your head, you can always take 216 and divide it by 2. Do the opposite. What's half of 216, or 216 divided by 2? 108. That means that 2 times 108 is 216. Well, if we multiplied the second terms by 108, what would we have to do with the first terms? That's right, we would also need to multiply it by 108. 1 times 108 is 108. That means that y is equal to 108. Do you remember what y represented? Well, since y represented the number of students who buy their tickets at the door, we can conclude that therefore 108 students who attend the dance buy their tickets at the door. So this was just one method of solving this question using equivalent ratios. But remember, there are many different ways you can solve this problem. Check out our playlist to see different solutions.